Hello everybody, welcome into another lesson. So today we are going to talk about using inverse matrices to solve systems of equations. In this particular lesson we're going to do it on a two-variable system of equations, so this shouldn't be too bad. Now, full disclosure, a couple things. One, this is a viable method to solve systems of equations. Now, having said that, part two, this is probably not the most preferred method. Your best method, honestly, of all we've learned so far, and this is really coming down to the end of the matrices unit, your best method is honestly to just use elementary row operations and either get it into row echelon form with back substitution or reduced row echelon form and solve it that way. Cramer's rule is the next best, but this is the least preferred, but I still got to teach it because this is a viable method for solving systems. So if you look here, you have your system of equations. You have your x and y variables with various coefficients on those, and then to the right of those equations you have what those are equal to. In general, the idea is you can separate the coefficients themselves of the x and y variables into a 2 by 2 matrix. We'll call that matrix A. And then you have a matrix X, which is just the variables x and y. So that is going to be a 2 by 1 matrix. And then you have a matrix B, which is what those equations are equal to, another 2 by 1 matrix. The idea is you could take matrix A times X and set that equal to B. And if you actually do the matrix multiplication, you'll get this whole system back. This is just a way to set it up so you can take the inverse of matrix A and solve. Well, so you have AX equals B. Well, once you find the inverse of matrix A, what you can do is take A times A inverse times matrix X. That would be equal to A inverse times B, which in short, A times A inverse would give you the identity matrix times X, which would be equal to A inverse times B. Well, the identity matrix is the equivalent of multiplying by 1. So what that really is going to turn into is that the value of matrix X is equal to A inverse times B, and matrix X is your x and y, so that gives you your direct values for x and y. So let's demonstrate here with some equations. Alright, or some systems I should say. So we have the first system, we have x plus y equals 5. Then we have 3x minus 4y is equal to 8. Alright. So there's our first system. We have x plus y equals 5, 3x minus 4y equals 8. Why don't we go ahead here and list our matrices? So matrix A is simply just going to be a 2 by 2 matrix with the coefficients of x and y. So in the first one, your coefficients are both 1 and 1. The second row, your coefficients are 3 and negative 4. Alright, so there's your A matrix. Your X matrix is simply going to be a 2 by 1 matrix with the variables x and y. So there's A and there's X. And then you have your B matrix, which would be another 2 by 1 matrix with the entries 5 and 8, which are to the right of the equal sign. So the idea is that A times X would equal B. And if you did that, you would get this system right back. Well, what you want to do now is find the inverse of matrix A. And remember, to find the inverse of a 2 by 2 system, you take the determinant of that matrix A first. So let's find the determinant of A. So 1 times negative 4 is going to be negative 4 minus 1 times 3, that'd be minus 3. Your determinant itself is going to be negative 7, okay? Now, that we know the determinant of matrix A, we can proceed to find the inverse of A. So the inverse of A is going to be 1 over the determinant of A, which is -7, which this all becomes your scale factor. Now to do the inverse of the matrix itself, then, you'll switch your A and D. So -4 would come up here, 1 would come down here, and then your B and C coefficients would stay in the same spot, but you negate them. So this would become -1 and then -3. So what you're going to do now then is take this -1/7 and multiply it through your matrix. So -1/7 times -4 turns into +4/7. -1/7 times -1 turns into +1/7. -1/7 times -3 turns into +3/7. And then -1/7 times +1 is -1/7. So we have now found our A inverse. Our A inverse is this matrix right here. Well, to find X, all you got to do is take your A inverse times your B, which is going to be, of course, this whole inverse matrix of 4/7, 1/7, 3/7, and -1/7 times your B matrix of 5 and 8. So you have a 2x2 times a 2x1. Your resulting matrix should be a 2x1, which will give you direct values of X and Y. So if we do the multiplication, let's see, you'll end up getting 4/7 times 5 plus 1/7 times 8. And then for your second row, you'll get 3/7 times 5 minus 1/7 times 8. Which would end up then giving you, let's see here, 4/7 times 5 is 27 plus 8/7. Then the second row, 3/7 times 5 is 15/7. Minus 1/7 times 8, that'd be minus 8/7. And then what do you know? That gives your X values to be 27 plus 8/7 is 28/7, which would be 4. The second row, then, you would end up having 15/7 minus 8/7 plus 7/7, that'd be 1. So now your X matrix has values of 4 and 1. That first one, it tells you X is 4, Y is 1. So the ordered pair that's going to be your system of equations, for the system of equations, the solution to it would be 4, 1. So that is how you use an inverse matrix to solve a two-variable system of equations. And it goes down much the same way with the 3x3, only it's not going to be as pretty. So we got some more examples here. I'll definitely do more examples. So you should already be beginning to see why this is not a preferred method of dealing with solving systems of equations. Alright, next one. We are given x plus 2y equals 6. Then we have 4x minus y is equal to 5. Alright, so we have x plus 2y equals 6, 4x minus y equals 5. Well, let's go ahead and form our separate matrices here. So matrix A is nothing more than a 2 by 2 matrix with your coefficients of x and y. So in the first row, you'll have 1 and 2 for your coefficients of x and y. Second row, you'll have 4 and -1 for your coefficients of x and y. Your X matrix, well, that's nothing more than a 2 by 1 matrix with just X and Y. Then your B matrix is going to be nothing more than those 6 and 5, a 2 by 1 matrix with entries 6 and 5. Alright, so now we have our separate matrices. We know that A times X equals B. Let's proceed to finding A inverse. First, we got to find the determinant of A. The determinant of A is going to be 1 times -1, which is -1, minus 2 times 4, which is -8. So your determinant value itself is going to be -9. Okay. So to start finding A inverse, that's going to be 1 divided by your determinant of A, which is -9, times, that becomes a scale factor, times what we got to do with matrix A. So your A and D's will switch places, so -1 will come over here, 1 will come down here. Your B and C coefficients stay in the same spots, but you just negate them. So this will become -2 and then -4. Which would give you your A inverse. If you do the scalar multiplication, that would be +1/9, +2/9, +4/9, and then -1/9. So there is your A inverse, 1/9, 2/9, 4/9, and -1/9. Now, we can take X, set that equal to A inverse times B. So let's go ahead and do that here. That's going to be equal to this A inverse, which is going to be the 1/9, 2/9, 4/9, -1/9, all times your matrix B, which is just 6 and 5. So you should get a 2 by 1 matrix. So let's see, for your first row, you'll get 1/9 times 6 plus 2/9 times 5. For your second row, you'll end up getting 4/9 times 6 minus 1/9 times 5. Alright, so let's simplify this more. 1/9 times 6. I think we're going to leave everything with a denominator of 9. I know that's not proper form, but keep your denominator the same if you have the same denominator. So that would be 6/9 plus 2/9 times 5. That'd be plus 10/9. And then for the second row, you'll have 4/9 times 6. That would be 24/9. Minus 1/9 times 5th. That'd be minus 5/9. So to simplify this more, let's see, so 6/9 plus 10/9 is 16/9. That doesn't reduce any further, unfortunately. Now 24/9 minus 5/9, that's just 19/9. So that's your X. 16/9 and 19/9, that's your X matrix, meaning the ordered pair that's the solution is going to be 16/9, 19/9. So yes, this was not pretty at all. But that would be the solution to this particular system of equations. 16/9, 19/9. 19/9, not 19/19, excuse me. So there's the ordered pair, that's the solution. I got about 4 more of these. what is the next one here? So we have 5x minus 3y is equal to 9. Then we have negative 4x plus 2y is going to be equal to 10. Alright, so here's your system: 5x minus 3y equals 9, negative 4x plus 2y equals 10. Well, again, form your separate matrices here. So matrix A is just the coefficients of your x and y variables, which will be a 2 by 2 system. So first row is that 5 and that negative 3. Second row is that negative 4 and 2. So there's your A matrix. Your X is just simply a 2 by 1 matrix with the variables X and Y. Your B matrix will be a 2 by 1 with everything to the right of the equal sign with entries 9 and 10. Alright, so now we got the separate matrices here. We want to proceed with finding A inverse to solve the system, but first let's find the determinant of A. So the determinant of A, well, what's 5 times 2? That's going to be 10 minus negative 3, which is plus 3 times negative 4. That'd actually be minus 12, giving you your determinant value of negative 2. So to find A inverse, you'll take 1 and divide it by your determinant of A, so 1 divided by negative 2, which becomes a scale factor. Now, for your inside your matrix A, you need to take your A and D and switch places with those. So 2 would come up here, 5 would come down here. Keep your B and C coefficients in the same place, but negate them. So negative negative 3 turns into positive 3, negative negative 4 turns into positive 4. So now just take that negative 1/2, multiply it through your matrix. Negative 1/2 times 2 is negative 1. Negative 1/2 times 3, well, that's just negative 3/2. Negative 1/2 times 4 is negative 2. Negative 1/2 times 5 is negative 5/2. So there's your A inverse matrix. Doesn't look as pretty as the original because you got fractions, but now that we found our A inverse matrix, the idea is that X is going to equal A inverse times B, which means that X would equal that inverse matrix itself of negative 1, negative 3/2, negative 2, negative 5/2, times your matrix B, which had entries of 9 and 10. So let's do that matrix multiplication. So this would become negative 1 times 9 minus 3/2 times 10. Then you'll have negative 2 times 9 minus 5/2 times 10. So then let's simplify this a little more. Negative 1 times 9, that's just negative 9, minus 3/2 times 10, that would be minus 15. Then you have negative 2 times 9 is negative 18, minus 5/2 times 10, that's going to end up being minus 25. So that means X is going to have a 2 by 1 matrix with a solution of negative 9 minus 15 is negative 24. And then you have negative 18 minus 25. That's going to be negative 43. So you have negative 24, negative 43. So that means the ordered pair that's your solution is negative 24, negative 43. Yep, that one's out there, isn't it? But yeah, negative 24, negative 43 would be the ordered pair that's the solution to this. I got about 3 more of these. Alright, so let's see. We have 2x minus 5y is going to be equal to negative 11. Then we have negative 3x plus 7y is going to be equal to 15. Alright, so 2x minus 5y equals negative 11. Negative 3x plus 7y equals 15. Well, let's form our three separate matrices first. So again, matrix A is just a 2 by 2 matrix with the coefficients of the x and y variables. So in the first row, you'll have 2 and negative 5. In the second row, you'll have negative 3 and positive 7. So there's matrix A. Matrix X is just simply going to be a 2 by 1 with variables x and y. And then matrix B will be everything to the right of the equal signs, another 2 by 1 matrix. So it'll be negative 11 and 15. Alright, so we formed our three separate matrices. Now, first thing we want to do is find the inverse of matrix A, but in order to do that, we need to find the determinant of A. So the determinant of A, in this case, 2 times 7 is going to be 14. Minus negative 5 turns into plus 5 times negative 3. That'd be minus 15, which would give you a determinant of negative 1. Alright, so the determinant's negative 1. Now to find A inverse, that's going to be 1 divided by your determinant of negative 1, which, as we know, would just make that scale factor simply negative 1. Now take your original matrix, switch the places of A and D, so 7's going to come up here, 2's going to come down here, and then you have your B and C coefficients you'll leave in the same place, but you'll negate them. So negative negative 5 turns into positive 5. Negative negative 3 turns into positive 3. So now just take your scale factor of negative 1, multiply it all the way through. You'll end up getting negative 7, negative 5, negative 3, negative 2 for your inverse matrix. So there is your inverse matrix of A. So now we know that X is equal to A inverse times B, which means we're going to take that inverse matrix, so negative 7, negative 5, negative 3, negative 2, multiply all that by matrix B, which was negative 11 and 15. Okay. So let's go ahead here. Negative 7 times negative 11 is 77, plus negative 5 times 15, well, that's going to be minus 75. And then we have negative 3 times negative 11 is 33, plus negative 2 times 15, that'd be minus 30. So in short, you'll end up getting your X matrix having a value of 2, then 3. So the ordered pair that would be the solution to this system would be 2, 3. I know it seems like a lot of work, but again, I do have to teach this. This is a viable method. Okay, I only got 2 more for this lesson. So let's see, I have x plus 8y is equal to 4. Then I have 4x minus 5y is going to be equal to negative 11. So this system here, we have x plus 8y equals 4, 4x minus 5y equals negative 11. Well, let's go ahead and set up our three separate matrices here. So matrix A, again, is just simply the coefficients of your x and y variables. So in the first row, you'll have 1, then 8. Your second row, you'll have 4, and then negative 5. So there's your A matrix. Your X matrix is a 2 by 1 with simply the variables x and y. Then your B matrix is everything to the right of the equal signs, which would end up being 4, negative 11. Alright, so there's your three separate matrices. Now, we want to start out by finding A inverse, but in order to do that, we need to know the determinant of A. So let's find that determinant first. Well, 1 times negative 5 is negative 5. Minus 8 times 4, that'd be minus 32. Wow, that's horrible. Gives you a determinant of negative 37. Yeah, not pretty, is it? Okay, so in order to find A inverse, you'll take 1 over your determinant of A, which is negative 37. We know this will turn into negative 1/37 and become the scale factor for this matrix. Now your A and D variable, A and D coefficients switch places, so this negative 5 would come up here, 1 would come down here, and then your B and C coefficients stay in the same place. You'll just negate them, so you'll have negative 8 and negative 4. Now you just do the scalar multiplication through your entire matrix. Negative 1/37 times negative 5 is positive 5/37. Negative 1/37 times negative 8 is positive 8/37. Negative 1/37 times negative 4, that's going to be positive 4/37. And then negative 1/37 times positive 1 turns into negative 1/37. So there is your hideous A inverse matrix. Now, X is going to be equal, of course, to A inverse times the B. So let's take our A inverse matrix of 5/37, 8/37, 4/37, and then negative 1/37. Making sure it's still going, right? Okay, good. And then times the B matrix of 4 and negative 11, which should give you a 2 by 1 matrix to tell you what X is equal to. So you'll take 5/37 times 4 plus the 8/37 times negative 11. Then you'll have 4/37 times 4 plus your negative 1/37 times that negative 11. All right, so let's simplify a little more. This would give you 5/37 times 4 is 20/37. This would be then minus 88/37. And then 4/37 times 4 is 16/37. Negative 1/37 times negative 11, this would end up being plus 11/37, which is going to give you negative 68/37 and then 27/37. Yeah, not a pretty solution, is it? So that's your X matrix now, is negative 68/37 and 27/37. So your ordered pair, that's your solution, is going to be negative 68 37ths, and then 27 37ths. So there's the ordered pair as a solution. Negative 68 37ths and then 27 37ths. I got just one more problem, then we're done with this lesson. Alright, what is the next one here? Didn't quite want to go there yet. Alright. 2x minus 5y is equal to 4. Then we have x minus 3y is equal to 1. Alright, so there's our last system of the lesson. So we have 2x minus 5y equals 4, x minus 3y equals 1. Well, let's go ahead and set up our three separate matrices here. So A is just a 2 by 2 matrix with all the coefficients of x and y. So you'll have in the first row that 2 and that negative 5. The second row you'll have the 1 and negative 3. So there's your matrix A. Your matrix X is just simply a 2 by 1 matrix with variables x and y. Then your matrix B is everything to the right of the equal sign, another 2 by 1 matrix with entries 4 and 1. Alright, so there's your three matrices. First thing we want to do, again, find the inverse of A. But in order to do that, we need to know the determinant of A. So the determinant of A is simply going to be 2 times negative 3, which is negative 6, minus negative 5 turns into plus 5 times 1. That would be plus 5, giving you a determinant value of negative 1. So now to find your A inverse, you'll take 1, divide it by the value of your determinant, which is negative 1. We know this would just turn into negative 1 for your scale factor. Now for your matrix here, you take your A and D and switch places. So the negative 3 is going to come here, the 2 is going to come here. You leave your B and C coefficients in the same places, but you negate them. So negative negative 5 is positive 5. Negative 1 here. So now just take your matrix, multiply it by negative 1. That's going to give you, see, negative 1 times negative 3 is positive 3. Negative 1 times 5 is negative 5. Negative 1 times negative 1 is positive 1. Negative 1 times 2 is negative 2. So here is going to be your inverse matrix, 3, negative 5, 1, and negative 2. Now we can find x by taking that A inverse times matrix B. So let's take our inverse matrix here, which would be 3, negative 5, 1, negative 2, multiply it by our matrix B, which was 4 and 1. So we should get a 2 by 1 matrix. That's the solution to x. So you'll take 3 times 4 minus 5 times 1. Then for the second row, you'll take 1 times 4 minus 2 times 1, which would end up, of course, giving you 12 minus 5, and then 4 minus 2, which means your X matrix is going to have entries of 7 and 2. So X has values of 7 and 2, which means X has a coordinate of 7, Y a coordinate of 2. So the ordered pair that's the solution to this system is going to be at the point 7, 2. So that's it for using inverse matrices to solve for 2 by 2 systems. Next lesson we'll use them to solve for 3 by 3 systems. Then after that, we're done with matrices. We're actually done with all linear stuff. We'll go on to quadratic equations then, and quadratic functions, and graphing them after that. So I hope everyone has a great day. Take care.